this is Captain Chaudhari in my series of videos on marine astronomical navigation. We were doing some calculations. In my last video, I talked about Napier's method of doing the calculations in respect of spherical triangles. In the last video, we talked about sun rising, we talked about sun crossing observer's prime vertical, and we also talked about a condition that is required for a body to cross observer's prime vertical, and that is latitude and declination should be same name and declination should be less than or equal to the latitude. Now if we change the condition a little bit and we say that the latitude and declination should be same name and declination should be more than latitude, is a condition that the body will not cross observer's prime vertical and the body during transit will reach maximum azimuth on east and maximum azimuth on west. So whenever a question talks about the body attaining maximum azimuth on the east or west, it indirectly tells you that latitude and declination are of same name and declination is more than latitude. Let's say I will decide the numerical after I draw the diagram. Let's make an observer's rational horizon diagram, right? North south, and let's say the latitude is 30 degrees north. And the declination is 48. The pole is over here because this latitude is 30 degrees north, and the body transits in her passage like this. This is a favorable condition for the body, to be seen at maximum azimuth. Okay, so this is the point at which the body is going to attain maximum azimuth. When the body rises over here, the azimuth is low, and the azimuth keeps increasing till it attains the maximum azimuth, and thereafter once again the azimuth is going to reduce, right? So this point of maximum azimuth could be considered as a point where this parallel of declination circle would be tangenting the observer's vertical circle passing through the body. It is perpendicular to this observer's vertical circle through the body, and therefore we say that this angle is 90. So whenever we talk about a situation where latitude and declination are same name and declination is more than latitude, it gives rise to a situation of maximum azimuth, and at the time of maximum azimuth, angle x is 90. This angle x in navigation is also called parallactic angle, very less spoken angle. People don't much talk about this angle. This is angle that is parallactic angle, right? So this is P, this is Z, this is X, this angle is 90. How much time will the body take? The time taken for the body after the star rises till maximum easterly azimuth. That is the question. How much time the body will take from the time of rise till the time that body attained maximum azimuth. Whenever we talk about time, we have to capture this angle P. So we want to capture this angle of star's meridian from the time it rises till it attains maximum azimuth. This is what we have to do, and therefore we need to solve two spherical triangles. One is PZX and other one is PZX1, right? So let's first attack this bigger angle P that is at the time of rise, right? Okay, now we are given the declination of the body as 48 degrees north. So can we say Px is 42 degrees? And because we have the latitude as 30 degrees north, can we say that the side PZ is 60 degrees? And then what is this angle P that is contained? So once again we make a Napier circle. Napier circle, whatever is 90, write down on top Zx equal to 90 degrees. The neighbors of Zx are Z and X, and subsequent neighbors like neighbors of Z are Zx and Pz, neighbor of X are Zx and Px, and the remaining angle P. So we need to find out what is angle P, and we have Pz and Px. So we have an equation, sine of middle part, that is 90 minus P, is equal to tan 90 minus Pz tan 90 minus Px. And because we are talking about a situation where the side is 90, we will be introducing a negative sign on the right hand side, so that is minus 1. Tan 90 minus Pz is 1 upon tan Pz, and tan 90 minus Px is 1 upon tan Px. So this is minus 1 upon tan 60 and tan 42 degrees. Minus 1 divided by bracket gives me 129.88, so 129.9 degrees. So P is equal to 129.9 degrees. So that is the angle subtended by the meridian passing through the star, that is the celestial meridian passing through the star till the meridian, till the star is at meridian passage. So that big angle which you see is 129.9 degrees. Now let us find out what is the angle P, that is the, as you can see, this angle is on the east side, the angle EHA, when the star is at maximum azimuth. So for that we will have to put in the Napier circle the angle x1 equal to 90, and in the circle the sides of x1 are px1, zx1, pz, pz. Now here we have angle x as 90, so there is no question of introducing a negative sign. Once again we want to find out angle P, and the sides that are known to us are once again pz and px, right? So we have these three parts which are clustered together. So sine of middle part, that is sine of 90 minus P, is equal to tan px1 into tan 90 minus pz, so it will become 1 upon tan pz. This means cos P is equal to tan 42 divided by tan 60. Gives me 58.68 degrees, or 58.7 degrees we can say. So angle P is equal to 58.7 degrees. So 58.7 degrees is this angle, and the larger angle is 129.9. So what is the angle from the time the star rises till it attains the maximum azimuth? So that would be given by 129.9 minus 58.7 divided by 15.041, which is the rate of change of meridian or GHA by a star per hour, 15.041. So let's see, 129.9 minus 58.7 equals divided by 15.041 gives me 4 hours 44 minutes, and you can say 1.4 seconds. This is the time that the star would take from here till the maximum azimuth. What is the maximum azimuth, maximum easterly azimuth that would be attained? Let's take the original things which are given to you, that is the px and pz. Px because we know the declination, and pz because we know the latitude. So you can see that these parts are not together, they are scattered. So I'll use second rule, and second rule is sine of middle part, that is sine of px is equal to cos opposite cos 90 minus z cos 90 minus pz. So this means sin px is equal to sin z sin pz, and therefore sin of z is equal to sin px upon sin pz. Now I told you, whenever the cos or tan is negative, it gives a warning that the angle is in second quadrant. Sine does not give any such warning, but we can look at the diagram and see for yourself, right? See very clearly on the diagram that this z, angle z, I 100% know is less than 90 degrees. So there is no question of ambiguity here, right? So let us find out how much is this angle z. So we have sine 42 degrees, 50.6. So angle z is equal to 50.6 degrees. So that is the maximum azimuth. So this is how we can do the calculations whenever question says maximum azimuth. That means angle x or parallactic angle is of 90 degrees, and we can do the question using the Napier's.